Hi everybody. Today we're going to go through our first lesson in Unit 10. We're going to be talking about Pythagorean theorem and its converse. I know in the last unit we briefly talked about Pythagorean theorem, but today we're going to talk about it in a little bit more detail. So the Pythagorean theorem says that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. We're probably more familiar with Pythagorean theorem, the equation, that's associated with it, Pythagorean equation, a squared plus b squared equals c squared. Where a and b are the two leg lengths of the right triangle, and c is the hypotenuse length. So we're going to go through a couple of examples here. So the first one says find the length of AC. So because I have a right triangle, I can substitute the three side lengths into the Pythagorean equation. I want to make sure that I put the hypotenuse length in for the c squared. Because I have kind of like a quantity here with a number outside the radical and inside the radical, I'm going to put parentheses around it. I'll talk about why I'm doing that in a second. But then I'm going to fill in the a and the b in Pythagorean equation, which are the two leg lengths. Order doesn't matter with a and b. If you wanted to write 4 squared plus x squared, that's fine, because order of addition doesn't matter. I'm going to go ahead now simplify my exponents. So I can't simplify x squared anymore, but I can simplify 4 squared, which is 16. Now, the reason I put parentheses here is to remind myself that when I'm squaring something, it means I'm taking whatever I have in parentheses and multiplying it by itself. When we're multiplying radical expressions, we want to multiply the like terms, which means the numbers outside the radical, so 2 times 2, which would give me 4, and then the numbers inside the radical. So 13 times 13 would give me 169 in the under the radical, but that's a perfect square. So the square root of 169 is 13. So technically this is just 4 times 13. Whenever we multiply the same radical by itself, it basically undoes the radical and just gives me the number that we have under the radical. So this is equal to x squared plus 16. X squared plus 16, if I simplify 4 times 13, that gives me 52. If I subtract 16 from both sides, that's going to give me x squared is equal to 36. I'm going through solving this quadratic by taking the square root. I can do that because I do not have a b term or an x term or a linear term. So when I go ahead and take the square root, technically the solutions to this equation are plus or minus 6. But I know that since x is a side length, I wouldn't have x be able to be equal to negative 6. So the only answer is x equals 6 because this can't be a negative side length. All right, so the next one says find the value of x, BC, and AC. So again, I'm going to go ahead and fill in the Pythagorean equation, and I'm going to first fill in the hypotenuse length, and then the order of the legs don't matter. So one of the legs is 5, one of the legs is x minus 1. I'm going to square both of those, add them together. And then I'm going to simplify the exponents. So 5 squared is 25. Remember, when we square something, and I'm putting it in parentheses here because it's a quantity, it means we're multiplying it by itself. So we are going to have to FOIL this or distribute. So that's what I'm going to do next. So the first terms, x times x, will give me x squared. If I do the inner and the outer terms give me minus 1x. The outer terms give me another minus 1x. which if I combine them, I'll get minus 2x. And then if I do the last terms, minus 1 times minus 1 is going to give me a plus 1. So if I want to now start to combine like terms, I'm first going to start to combine my squared terms. So if I want to take this x squared and bring it to the other side, I would subtract. But notice that they cancel out then. So I'm going to combine my constants. 25 plus 1 would give me 26 minus 2x, but there's nothing over here. So I'm going to bring my x terms to the other side by adding 2x. And then if I divide by 2, I'll get x equals 13. I was also asked to find BC and AC. So BC is x minus 1, so 13 minus 1 is 12. AC is just the value of x, so that's going to be 13. For the next one, it says Mrs. Howell is building a rectangular picture frame. She wants the ratio of the length to the width to be 3:1 and the diagonal to be 12 centimeters. So the diagonal is going to go across from opposite vertices of the rectangle, so that's going to be 12 centimeters. She wants the ratio of the length to be to the width to be 3:1. So I'm going to label the length 3x, and then I'm going to label the width 1x, or just x. Rectangles have 4 right angles, so I do have a right triangle. So I can go ahead and fill in the Pythagorean equation. I want to make sure that I get the hypotenuse in the right spot, so that's going to be the 12. And then I'm going to go ahead and fill in the 2 leg lengths. So I have x squared, and I am going to put parentheses because I don't just have a single variable or a single number. So I'm going to put parentheses around what I need to square, which is the 3x. And remember, when we square something, it means you're multiplying it by itself. So 3x times 3x, the 3 times 3 is going to give you 9, and then the x times the x is going to give you x squared. So I'm going to combine my like terms. X squared plus 9x squared is going to give me 10x squared equals 144. Again, I'm going to go through solving this quadratic by taking the square root because I don't have a b term or an x term. So I want to isolate x squared. So I want to get rid of this 10. And then I'm going to take the square root of both sides. I'm going to use my calculator. If I take the square root of 14.4, I get x equals 3.8 about. So the width is going to be 3.8 centimeters. If I multiply that by 3 to get 3x, which is the length, I'm going to get about 11.8 centimeters. So there are my dimensions. All right, the next example says, if the perimeter of square ABCD is 20 inches, find the length of AC. So I'm going to draw a square. I'm going to pick a vertex to start labeling. So I'm going to start A here, and then I'm just going to go around the square in the order that's named here. So A, B, C, D. I want to find the length of AC, so that's this diagonal I'm going to draw in. And squares also have 4 right angles, so I want to find the length of AC. The other piece of information that I'm given here is the perimeter of this square is 20 inches. A square has 4 congruent sides, so if the perimeter is 20, if we divide 20 by the 4 sides, we're going to get each side length is 5 inches. So I have 2 right triangles that are exactly the same. But because I have right triangles, I can use the Pythagorean equation in order to find the length of AC. So AC, the side length I'm trying to find, is the hypotenuse. So I'm going to fill that in because I want to make sure I get the hypotenuse in the right spot. And then I'm going to fill in the two leg lengths, which are each 5. I'm going to simplify the exponent. So 25 plus 25 equals x squared. So that's 50. Take the square root of both sides. I do want you to put these answers in simplest radical form. So the square root of 50 can be broken down to 25 times 2, 25 being the perfect square. So if I take the 25 out of the radical, I'd want to actually take the square root of it. So I'm bringing the 5 out, but I'm leaving 2 under the radical. So AC's length would be 5 times the square root of 2. The next theorem we're going to go through is the converse of Pythagorean theorem. Basically what the converse says is if you can find 3 numbers, the largest of which is the C value that fit the Pythagorean equation, then your triangle is a right triangle. So for example, if I chose 3 numbers, I'm choosing 3, 4, 5. The largest of those is going to be my C value. If these fit Pythagorean equation, like this, I know that any triangle with the side lengths 3, 4, 5 have to be a right triangle. So let's see if this works out. So 3 squared is 9, then 16, then 25. 9 and 16 added together does equal 25. So what this says is if you have a triangle with sides 3, 4, 5, it has to be a right triangle where the largest side is the length of your hypotenuse. Based off of that, we have 2 Pythagorean Pythagorean inequality theorems, which basically tell us how we can determine if we have an acute or an obtuse triangle. So you can read these theorems, word for word if you want to, but basically what you need to take away from these inequality theorems are these 2 sentences that I put a box around, which basically say now, instead of having an equal sign separating the a squared, b squared, and c squared, we have inequality symbols. So if we have 3 numbers that represent the side lengths of triangles, if we put the largest value in for C and the 2 smaller ones in for A and B, well, what happens if A squared plus B squared does not equal C squared? Like 3, 4, 5 happen to fit into the Pythagorean equation, but what if we choose 3 numbers that don't fit into that equation? Well, we can tell then, based on the way the inequality symbol opens up, whether that triangle is going to be an acute or an obtuse triangle. So I think this makes a little bit more sense when I actually use numbers. So I'm going to do that here for the next example. So I'm going to take these 3 numbers, 5, 7, and 10, and I'm going to decide what type of triangle I have. When you're determining the type of triangle, you always want to pick the larger number, the largest number, and make that the C value. The other 2, in no particular order, are going to be A and B. And then I'm going to fill in Pythagorean theorem. But I'm going to leave a space here. So I'm not going to put an equal sign because I don't know if it's actually going to be an equation. It might be an inequality. So I'm not sure if there's going to be an equal sign here. So I'm going to leave a gap between the A squared plus B squared and the C squared. It is important, though, you choose the largest number for the c squared. That has to be the case for these inequality theorems to work. So c is going to be 10, so I'm going to square that. And then a and b are 5 and 7. And again, I'm leaving a large gap here because I don't know if these two quantities are going to be equal. Now I'm going to, if I need to, pick up my calculator and simplify the exponents. So I get 25 plus 49, and I'm going to compare that to 100. If I add 25 and 49, I get 74, and I have to compare that to 100. So 74 does not equal 100. It's that 100 is greater than 74. So in this particular example with these three numbers, the c squared was greater than the a squared plus b squared value. When c squared is greater, it means that you're going to have an obtuse triangle. Remember, if this were an equal sign, it means it fits Pythagorean equation, and then it would be a right triangle. If it doesn't equal, though, it's either going to be an acute or an obtuse triangle. So because c squared was greater, 100 was greater than 74, this triangle with these three side lengths would be, it would be an obtuse triangle. All right, and then one more example of this. So again here, we want to fill these numbers in to decide if we have a right triangle, an obtuse triangle, or an acute triangle. And again, I'm going to leave a gap here because I don't know if it's going to be equals, greater than, or equal to. In order to figure it out, I need to put in the largest of the three numbers in for c. So 5.2, I'm going to have to square it. That has to go in for c. The other two numbers in any order are going to be a and b. And again, I'm leaving a gap because off the top of my head right now, I don't know which side is greater or if the two sides are equal. I am going to use a calculator to square these. So 3.8 squared is going to get me 14.44. 4.1 squared is going to get me 16.81. I'm going to leave a gap, and then I'm going to square 5.2, which is 27.04. I'm going to add these two numbers together. So that's going to be 31.25. And I'm going to compare 31.25 to 27.04. Well, obviously they're not equal. It is that the 31.25 is greater than the 27.04. And the 31.25 came from the a squared plus b squared. This was the c squared. So in this problem, a squared plus b squared was greater than c squared. If that happens, you have an acute triangle. If you can't make a triangle with these three side lengths, then you're not going to have any type of triangle. Remember, we did that a couple units ago where you had to double check if you add together any two sides, are they greater than the third? Yes, yes, yes. So these three sides can form a triangle. In the last example, those three sides could form a triangle. On the off chance you have a homework problem where the three sides can't form a triangle, well then you're not going to have any acute right or obtuse triangle because with the three sides you can't actually make a triangle.